Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 53, maximum subarray. So for this problem, we're given an integer array called nums, and we want to find the subarray with the largest sum, and just return its sum. So before we get into the actual code itself, we'll go through a few examples on how a potential algorithm could work. An intuitive idea to solve this problem might be to simply just enumerate all these subarrays from a given array and return the sum of the subarray that gives the largest sum. If we list out all the subarrays for the first example, we can see that we have 6 subarrays. So we have -2, 1, 3, and the 2 element subarrays, and finally the 3 element subarray. It's important to note that all these subarrays are contiguous. That means if we have a subarray such as -2 and 3, this would not be valid for this problem. Now I'll go ahead and list out all the sums for each of the subarrays. We can clearly see that the maximum subarray for this given array is the singleton element 1, so the return for this example is 1. If we analyze the time complexity for this, we can see that this is exactly a nested for loop because we have to keep track of the first left pointer and the right pointer. And for each iteration of the given array, we have to iterate from some index I to the end of the list and calculate its sum. Because of this, we have a time complexity of O of n squared. Now that we have some intuition as to a potential algorithm, we'll go ahead and code it up. So to start off the code, we can begin by initializing the largest sum for the subarray that we've seen. So we can just simply say largest, and we'll initialize this to the first element in the array. Next, we're going to loop over the entirety of the array, and we're going to also keep a current sum for each subarray. Next, we're going to loop over from some index I to the end of the list, as we've done in previous videos. Then we're going to increment the current sum based on each element that we add. Finally, we have to update the largest value if it has changed. So we'll just simply say largest is equal to the maximum of the current largest or the current sum. And we'll just return largest at the end of the algorithm. As you can see, because this is running in quadratic time, this is going to actually time out, even though it is a correct algorithm. So we must devise a faster algorithm to solve this problem. Looking at the second example, we can actually solve this problem using one traversal throughout the array. For example, if we begin with the subarray containing only -2, we see that the sum is -2. But if we include the element 3 in the subarray, we see that the sum of the subarray is 1. Basically what this means is that the -2 has no impact on the maximum subarray. We can refer to this as a negative prefix. And this is going to have no impact on the maximum subarray. So we can actually just keep our maximum subarray to only be 3. And this is larger than any subarray that we've seen thus far. Continuing with the algorithm, we must include any negative elements that follow a positive value. For example, if we have -3, we should include it. So we have a running sum of 0. This is because if we add further elements into the subarray, we might get a value that is the new maximum subarray. So finishing this algorithm, it will return 7. And the time complexity for this algorithm will only be O of n because we're only traversing the list once, and the space complexity is O of 1 since we're not using any additional data structures. We're only using variables to keep track of the maximum length that we've seen. With that being said, we'll go ahead and write up the code for this algorithm. So now we can go ahead and write out the optimal solution. We can again begin by setting the largest sum to simply be the first element in the array. Next, we can keep track of a current running total or a current sum. Next, we're simply going to iterate over the entire array. And we're going to check if the value of the current sum goes below 0. This is synonymous with saying that the sum has become a negative prefix and we can remove it if need be. So we can say if cur is less than 0, then we'll reset it to 0. Otherwise, we're going to simply add the current number and also update the largest if it has changed. And finally, we'll return the largest. As you can see, there's a lot of similarities with the brute force solution, but we're removing a lot of the unnecessary work that was being done in the first solution. With that being said, let's check this code out on LeetCode. As you can see, the code is accepted and this is the optimal solution. It's going to run in O of n time and have a space complexity of O of 1 because we're not using any data structures to maintain any memory. With that being said, hopefully you guys learned something and I'll see you guys soon.